Il est 13h30. Nous allons procéder à cette prochaine conférence. Re-sécuriser vos appareils IoT, donc Internet des objets. Alors, durant cette session, Cyrille N'Galé de Quarks Lab partagera les bonnes pratiques et un cas d'utilisation réel illustré par une démonstration sur la façon dont vous pouvez protéger et resécuriser vos appareils Internet des objets. Si vous avez besoin d'être protégé contre les pirates prenant le contrôle de vos appareils, contre la contrefaçon ou l'espionnage et même après le déploiement de vos appareils, alors je demanderais d'accueillir, s'il vous plaît, M. Cyrille N'Galé, Software et Data Protection chez Quarks Lab.
Thank you very much for this nice introduction. Can you guys hear me? I have no return from what I say, so I hope it's all fine. So I'm Cyrille, and I'm indeed a VP of Software and Data Protection at Quarks Lab. And during the talk today, I'm going to introduce a solution to a common issue in IoT projects, which is responding to cybersecurity incidents, and as a consequence, securing or re-securing an IoT device fleet even after it is deployed on the market. First, a few words about Quarks Lab. So, as I said, we are a French company specializing in cybersecurity software as well as consultancy services. And for the scenario of this talk, we are partnering with ST, that you probably know, a leading semiconductor company in the world, and Mender, which is a solution provider for software update on devices over the air. So let's get to the purpose of the presentation today. So in order to illustrate it, in fact, I will start with the following scenario. So here is an electricity company selling services to subscribers, and for that purpose they'll go ahead and deploy smart meters in the houses of those subscribers in order to report electricity consumption for billing purposes. So those smart meters contain a firmware which run the device, and that firmware itself contains a TLS certificated that themselves contain an authentication token. We will see later how it is used. So those firmwares are deployed on the smart meters using the OTA capability of an OTA service provider like Mender, for instance. And there we go. So the certificates in the devices are used in order to connect to the back-end servers of the service provider in order to report the real electricity usage of the subscribers for billing purposes. However, the designers of the solution didn't plan for an attack scenario like this. So an attacker has gone ahead, could get hold of the firmware that is in the smart meter. He could dump the TLS certificate that is included in there, and with that he can create a rogue device in which he will use the same certificate in order to report fake data to the backend, and therefore hinder the billing process, and by the same way jeopardizing the revenues of the company. In order to illustrate this attack, we went ahead and recreated the exact same scenario using the service from Mender to upload software on the device. Also using an IoT board from ST Microelectronics and an online IoT platform that we found on ourselves. And as you can see from the setup that we made, the devices are reporting the consumption in the IoT platform. Now let's switch to a terminal of a PC, for instance, on which we have extracted the firmware. So we go ahead, just do a simple string search in the firmware of the device, and we can find the private key that is used to connect to the backend. as you see in the first half of this picture. And then in the second half of it, we went ahead and we could also extract the HTTP frame that is used in order to communicate with that backend. And with these two informations, it's just so simple to create a simple script, as you can see here. 15 lines of scripting code with which we can send fake data to the backend, as we have all the connection informations, and also we know how to frame the information so that they are understood by the server properly. What you see in this next slide is that indeed we managed to intrude in the service, and the rogue device that we created is reporting consumption data here that are way lower than the normal consumption of the user, and therefore this will provoke loss of revenues from the company, which of course nobody wants when they run a business. So how can we help the company solving this issue? We designed a solution that will in fact create a new firmware that contains an individualized certificate per device, so that when this certificate is deployed on those devices, you will see how it operates and how we block the problem that was created. So how do we create this certificate? We simply generate a new certificate that will encode with a tool that we developed and store in a database that we sell as a product as well. This database is protected cryptographically, and therefore the information in there can only be read by a component that we developed ourselves as well. So with this protected data that we created, we will push them into a Mender configuration so that they are updated on the device. Then we modified the firmware that we extracted from the platform slightly. We add into that firmware product that we developed that will read the information that we stored in the blob that we created earlier. So pretty simple thing to do. And as you can see, when we upload this new firmware and configuration file on the device, and we try and run the attack that we created earlier, well, it doesn't work anymore. We get an error from that. So how does this all work? In fact, we simply pushed the new firmware on the device using Mender, and given that it is individualized, in fact, it excludes the rogue device by nature, given that it doesn't have this new generation of certificates. But the beauty of our solution is that even if the hacker now goes ahead and extracts the new firmware in the smart meters, he cannot use them because those firmware are attached to each of the devices, and therefore he will not recognize the rogue device on which it's running now, and then the server won't accept it. So as you can see, with a simple software solution without needing any hardware modification on the platform, we managed to solve that problem. We managed to put together a solution that clears an IoT, a real cybersecurity issue with a simple software update over the air. Our solution works with no need of any hardware component like a secure element or a TPM. It works on every embedded cloud platform out there basically, and it also can integrate with any device manager and IoT platform. The benefits of it is indeed that we could quickly respond to this incident by deploying a brand new solution on the same device, and by doing this we managed to help the company restore its service properly, even on the devices that were already deployed on the market. That's it. So if you want to know more about it, we have a stand in the 5th floor. Our stand is 809, and please feel free to come and discuss more about this with us. I think there was questions possible. If there's is there any question from the crowd?